Remember that absolute value is the distance a number is from 0. So if you had the absolute value of 2, well, that's equal to 2 because it's 2 units from 0. The absolute value of negative 3 is equal to positive 3 because it's 3 units from 0. Since absolute value means the distance a number is from 0, when I say that the absolute value of x is equal to 2, there's two numbers that are 2 units away from 0. There's positive 2 and negative 2. So this has two answers. My answers would be x equals negative 2 or x equals positive 2. But if I altered this slightly and said that the absolute value of x is less than or equal to 2, this would be all the numbers that are 2 units or fewer away from 0, which would be this area here, and then 2 units to the left as well. So as a compound inequality, this is that negative 2 is less than or equal to x, which is less than or equal to positive 2. It's all the numbers in between those two values. And my third scenario is when the absolute value of x is greater than or equal to 2. So that would be 2 units and further away from 0, which would be all these values to the right, like 3, 4, all the way to positive infinity, and to the left would be negative 2 and smaller. So this is going to be an OR statement. This is where I write two separate ones, where x is less than or equal to negative 2, or x is greater than or equal to positive 2. One writing issue I want to point out to you is an and right here. This is a compound inequality that is an and. Notice that your symbols move the same direction. That will always be the case when you order values from least to greatest, as long as your least value is on the right and your greatest value, your least value is on the left and your greatest value is on the right. Your symbols must always be less than symbols. It doesn't make sense for them to be switched other directions. Now in this one below, it would be normal or correct to have them go opposite directions. So this one's less than or equal to, this one's greater than or equal to. Those are two separate statements, so it's okay for them to face opposite directions. So the rest of this video, we're going to be solving absolute value inequalities. So I want to remind you of the two major cases. If you have the absolute value of x is less than or equal to 5, so whenever we had ones like this, less than, we wrote this as an and, which is where you have the x in the middle, and you're ranking things from least to greatest. So you have negative 5 and positive 5 to the left and to the right. Why is this? Because this is saying the absolute value of some number is less than 5 units away, so it ends up being graphed like this. Okay? The other case is where you have the absolute value of x is greater than or equal to 3. So this is where you split this into two separate ones using the word or, where we say x is greater than or equal to 3, or x is less than or equal to negative 3. And you graph this on the number line, having negative 3 and positive 3, close circles. Greater than values go this direction, so outward and outward. This one is a compound inequality known as the OR. So the rest of this video, you are going to be solving much more complicated ones like we did earlier in the year. Let's put these principles into action with a more complicated absolute value inequality. So the first thing I notice about this practice problem is that the absolute value symbols are on the right. I don't like that. It feels backwards. So the first thing I want to remind you to do is recopy this problem so that I have the absolute value of 2x minus 8 minus 12. That part's on the left, the 20 is on the right, and I need to make sure I flip my inequality symbol when I do that. It was eating the 20, it still needs to be eating the 20. So my second step says to isolate the absolute value expression. What I mean by that is this part right here needs to be by itself. So that minus 12 has got to go. So I am going to add 12 to both sides to get rid of it, which produces the absolute value of 2x minus 8 is still by itself, is less than 32. Now, you notice I said less than. So less than, this is where your inequality becomes a compound one because it's an and, it gets written like this. 2x minus 8 is in between two values. What two values? Positive 32 and negative 32 because that's how many units away from 0 it is. So again, notice that my symbols go the same direction when I'm dealing with an and. To highlight this. Okay, so now you're going to work your compound inequality, solving so that the x is alone in the middle. So I'm going to add 8 in the middle, so I need to add 8 on the right and the left. So negative 32 plus 8 is negative 24. Still have a 2x in the middle, and 32 plus 8 is 40. Okay, so again, looking at the middle, I need to get x alone, so I am going to divide by 2. Because I'm dividing by positive 2, my inequality symbols won't change. This gives me negative 12 is less than x, which is less than 20. This is known as my solution. All that's left to do is to graph my solution on a number line to show all the possible solutions. So I'm going to place negative 12 and positive 20. And I'm going to put an open circle on negative 12 and also on 20, and I'm going to shade this region in between. It's showing you again that negative 12 is the smallest x could be, and positive 20 is the largest, although it's not including those values. So any number in this shaded region is a solution. In this absolute value inequality, again, the absolute value expression is on the right side, so I'm going to recopy it so it's first on the left, which makes this negative 3 times the absolute value of 5x plus 3 is, now I need to switch my sign because I needs to be eating the side it originally was, is less than or equal to negative 45. So now I need to isolate my absolute value expression. So I'm going to divide both sides by the coefficient that's out front, that negative 3. It's held by multiplication, so the opposite is division. So I divide, and that produces the absolute value of 5x plus 3 is, now I need to remember I divided by a negative, so I'm going to flip the direction of my sign. Negative 45 divided by negative 3 is positive 15. Now that it's isolated, I am going to decide if it's an and or an or. So I read this out loud. That's greater than or equal to. So I go greater. This is an or. This is the one that gets written as two separate inequalities. One of them is exactly as I see. I just erase the absolute value signs. I kind of think of it as, where do they go? Well, they become these little arrows as I split it into two. The other one is 5x plus 3, and I do two things. I switch the symbol, make it less than or equal to negative 15. So it becomes less than or equal to, and it switches to the opposite value. And why is that? Because again, it's a 15 units away would be from here out, and 15 here and out, like that slide we looked at near the beginning of this video. So what do? I solve each of these separately. So I'm going to subtract 3. I get 5x is less than or equal to negative 18, and then divide by 5, and this is where some kids will type that in the calculator, but hopefully you recognize by now that that's just a fraction. Over here, subtract 3, get 5x is greater than or equal to 12, divide by 5, and I get x is greater than or equal to 12/5. So I'm just going to keep my word or in my solution, and I'm going to graph this on the number line. So I'm going to kind of make my number line in a lazy way. Negative 18/5 over here and positive 12/5 here. So my solution set will be closed circle because it's equal to on both, and I'm shading outward. All the values smaller or less than or equal to negative 18/5, and all the values greater than or equal to positive 12/5. So for this example, I'd like you to pause the video, try it on your own, and then check and see if you've got it right. If you have it right, there's no need to watch me go through this whole problem. If you need to, of course, watch the video. Okay, so here I go. In this absolute value problem, the absolute value part is already on the left, so I'm going to jump into isolating the absolute value expression. And again, when I say isolate, I mean you need to get this part here by itself. So I do that by adding 2 to both sides. which gives me the absolute value of 3x minus 6 is less than or equal to 18. Now that it's isolated, I look at the symbol. The symbol is less than. So since it's less than, I make this an and, where I write the absolute value part, the 3x minus 6. Sorry, struggling with my pen here. The absolute value of 3x minus 6, this just becomes 3x minus 6 is in between 18 and negative 18. So what do? I'm going to add 6 in the middle, which means I add 6 on the left and the right. I'm working two separate inequalities at one time. This gives me negative 12 is less than or equal to 3x, which is less than or equal to 24. I'm then going to divide by 3, which gives me negative 4 is less than or equal to x, which is less than or equal to 8. This is my solution, and when I graph it, I put negative 4 and positive 8. It's going to be a closed circle, and again, I'm shading the region in between. Something, again, I cannot highlight enough is when you are writing ands, your symbols had better go the same direction. If you ever write anything other than a less than or a less than or equal to right here and here, you will always be wrong.